Okay. Good morning, all. I given few problems. I sent few problems through WhatsApp. I think probably you might have taken the problems. Okay. I'll start solving one by one. What was the first problem given today? I will wind up the forced convection chapter. In this module, there are two chapters. One is forced and one is free convection. Forced convection chapter today I am going to wind up. Okay. From Tuesday, I am going to start the new chapter called free convection. That is also similar to the forced convection. There, only the velocity of the air which is blowing, or velocity of the fluid which is blowing over the surface, over the cylinder, inside the cylinder will not be given. Just it will be given, except velocity, all the data will be given. Okay. Okay. Today I will solve the problem. What is the first problem given here? Given a surface condenser consists of 200 thin walled, correct?
Yes, sir.
Each condenser consists of 200 thin walled circular tubes. Each tube is some diameter. So I take up the diameter. I take up that. So n, the number of tubes is 200. I'll take n as 200, and the diameter of each tube is 22.5 into 10 to the power of minus 3 meters. This is the diameter of the tube. And what is the length of the tube given? Length of the tube is 2 meters. Okay. And then the total fluid flowing through this tube, total mass of the fluid which is flowing through this tube is how much? That is m dot total. That is equal to 160 kg per second. And the temperature of the fluid which is inlet is T1. I take it as T1, 21 degrees centigrade. T2, outlet of the temperature is 29 degrees centigrade. Is asking you to find out the value of H. Okay. Whether velocity is given here? Velocity is not given. So whether we can consider this as a forced or natural convection? Here the students will go wrong. They will misunderstand. As I told, velocity is not given, then the problem is not considered as forced convection. No, not like that. You have to read the question properly and then analyze whether it is given or we have to convert. We'll see that, how to do that. So what is the first step in the forced convection? So what is the arrangement given? There are number of tubes, circular tubes like this, which are 220. I don't know how it is arranged. The tubes are arranged. And inside the tube, what is flowing? Inside the tube, water is circulating. Water is flowing. Inside the tube, all the tubes, water is flowing. If I consider all the tubes, the mass of the total mass of the water which is flowing is 160 kg per second. So what is the mass of the fluid which is flowing in one tube that we can divide? Because n is given, 160 total is known, you can divide and you can take out the mass of the fluid which is flowing in one tube. So before doing that, what is the first step we used to do in forced convection? We are going to find out bulk mean temperature. This is the first step we followed. So again, I am writing the entire thing because I think probably there was a 1.5 week gap. So if you want to find out the bulk mean temperature, the formula is Tm is equal to T1 minus of plus of T2 divided by 2. This is the bulk temperature of the fluid. T1 is nothing but inlet temperature of the water or a fluid. T2 is outlet temperature of the fluid divided by 2. You should take this. This formula is there in the data handbook. Very beginning of the forced convection, this formula is there. You can check out. Okay. And that bulk temperature is 21 plus 29 by 2. 50 by 2 is 25 degrees centigrade. So next is you take the properties. Properties of water at 25 degrees centigrade. If the properties of water at 25 degrees, if I take out, I think probably at 25 degree it is not there in that handbook. Properties at 25 degree it is not there. In the data handbook, if you check out, it is there for 20 and suddenly it is for 40. I hope. You check out.
Sir.
Do the interpolation, take the property at 25 exactly. Okay. If the properties of temperature, the temperatures are not there exactly, you have to do the interpolation. And you observe what is the fluid given. The fluid given is water. If the same problem, if I change, I can change this by telling air is flowing. If air is flowing, you take the properties with respect to air. If the water is flowing, take the property with respect to water. If the engine oil is flowing, take the engine oil. That's all. So I'll take a row. I'll write the values. What are the values I got? Kinematic viscosity, thermal conductivity, and Prandtl number. These 4 properties I have taken. So if you interpolate, you can take mu also directly. But now I am not taking mu. I have taken these values. No issue. You take the properties from the data and by interpolating. I got 998.75. Just to write the values. K is 605 and thermal conductivity is 605, 0.605, and this is 0.918 into 10 to the power of minus 6. This is 6.35. I got all these properties. So after this property, what is the general procedure? We'll go for finding Reynolds number. Finding the Reynolds number. Reynolds number formula is rho V D by mu. Hence, the value of mu is not there here. If you want, you can take out directly mu. Now I take a nu, so I take out this two and I'll rewrite this equation as V D divided by mu. That is also equation I can write here. Correct. But if you want to substitute here, very important thing, velocity is not given. Velocity is not given. If the velocity is not given, but mass of the fluid which is flowing is given, you can find out the velocity. How to find out the velocity? One problem we already solved. If the mass of the velocity is not given, instead of velocity, if he has given total mass of the fluid which is flowing in kg per second, I can take out the velocity from this. How to take out? I'll write here. I'll write in different colors so that you can. That is already solved. Still, once again, I'll refresh. So this is the formula. What is the formula for m dot? M dot is equal to rho a v. So what we want velocity. So velocity is equal to m dot divided by rho into area. So this is the formula I can use. And this formula I already used in the previous problem. You can check out. Substitute in place of v as this formula. M dot rho a v. So hence we are going to do for individual pipe. Don't do for entire pipe. You try to do for individual pipe. Later on you can multiply with m. So that here while substituting, you try to substitute m dot as for 1 tubes. M dot for 1 tubes. So can you tell what is m dot for 1 tube? This is separate formula, and m dot for 1 tube is equal to m dot total by n. So m dot total is 160 divided by 200. So what is the total mass of the fluid of one tube? 160 by 200. It is 0.8 kg per second. So in one fluid, one tube, that much of water is flowing. So substitute that here in the place of V. So Re is equal to m dot by rho A and D divided by kinematic viscosity. This is one term and that is other term. So here again, you will be having a doubt that what is area? The area is not pi dl. Area is pi by 4 into d square, diameter of the tube square. You check out this. You should not use pi dl for the area if you want to calculate the mass of the fluid flow, mass of the fluid which is flowing, or velocity of the fluid which is flowing. Area is pi by 4 into d square. You calculate the area. So I'll calculate that. Anybody calculated? So I got 4.9 into 10 to the power of minus 6. 4.9 into 10 to the power of minus 6 is the area of one tube. So substitute here, you'll get a Reynolds number as, what is the Reynolds number you got? So Reynolds number I got as 39992, correct? So something I got like that. You check out the values. I'm not sure. You check out the values. What is the Reynolds number I got? So once you get the Reynolds number, check out whether it is a laminar or turbulent. For laminar or turbulent, inside, if the fluid is flowing inside the tube, for laminar the value should be less than 2300. If it is greater than 2300, it will be turbulent. So now the value I got is 39,000, which is much greater than 2300. So we'll consider the type of the flow inside each tube is turbulent. So considering the turbulent flow, what I'll do? Considering the turbulent flow, Nusselt number of values, you're supposed to take, if it is a turbulent flow, you're supposed to take Ditters-Boelter's equation. That is 0.023 into Reynolds number to the power of 0.8 into Prandtl number to the power of n. That n depends upon whether the fluid is heating or cooling. You check out the temperature, inlet and outlet temperature. Inlet temperature is 29, outlet temperature is 21 and 29. So the fluid, whatever it is going, it is heated up. So this n value will be 0.4. Reynolds number right now we got, Prandtl number we get. Take out the value of Nusselt number. Once the Nusselt number is done, as usual, you know, Nusselt number is equal to H D by K. HD by K is the Nusselt number. Take out the value of HD by K. Oh, okay. Here the number of tubes are more, no? So the Nusselt number, what we are getting is for one tube. Later on, Nusselt number total, you calculate. That is Nusselt number into total number of tubes. You'll get Nusselt number total. Therefore, Nusselt number total will be equal to H D by K. So once you get Nusselt number total, substitute that, you'll get in terms of watts per meter square Kelvin. That's how you have to calculate the value of H. This is for total. H for total. If you want, you can calculate H for, okay, do one thing. By using this also, you calculate H. Multiply into 200 so that you'll get H total, or by using this also, you'll get this is H total and this is H. Show separately what is H for single tube and H total for complete all the tubes. Okay, I hope you have completed that. You complete that. I'll go for the next problem. Which is the next problem given? Air at 2 atmospheric and 200 degrees centigrade. Air at 2 atmospheric centigrade. Just to check out. Okay, I'll go with this. But first, before that, I'll go for this problem. In a condenser, water flows through 100 thin-walled circular tubes, because that is that problem what I'm going to dictate now, and this one is almost similar, so that I'm taking that. The fluid is water. Here also, the fluid is water, and instead of 200 tubes, there is 100 tubes. Arrange parallel m dot. I hope you can do this. This is almost that problem. I can check out. In a condenser, water flows through 100 thin-walled circular tubes arranged parallel. Now, that is the fourth problem what I given. That is the fourth problem what I given. You please take out the values, answers, and try to do by yourself. Take the answers and try to do by yourself. I tell the answers. I am telling about the fourth problem. In a condenser, water flows through 100 thin wall. Answer is H is equal to 633.42. H is equal to 633.42 watts per meter square Kelvin. 633.42 watts per meter square Kelvin. That is H total. And for H, one tube divided by 200, divided by number of tubes, that is 633.42 divided by n. N is 100 here. Number of tubes is 100. So that will be 6.33. 6.33. So almost the same type. That problem is almost same type. So we'll go for the next one. Okay, I'll go for this. Water at 25 degree centigrade flows through a tube of 50 millimeter diameter. This is somewhat small change in this problem. We check out what is the change to be considered compared to the other problems. The water at 25 degree centigrade flows through a tube. Again, the fluid is water. T1 is 25 degree centigrade, which is flowing through a tube of diameter 50 mm. 50 into 10 to the power of -3 meters. And the flow results in Reynolds. He has given Reynolds number directly. Reynolds number is 1600. So, which type of flow is this? Can you tell? Whether I am supposed to use Ditters-Bolter's equation? Ditters-Bolter's equation to be used only when the Reynolds number is greater than 2300 for tubes. Now it is 1600. I cannot use the Ditters-Bolter's equation. I have to use the Reynolds number, which is equal to the free convection, which is equal to the laminar flow. The tube is provided with the heating element on the surface and receives a constant heat flux. Q is given 800 watts per meter. The length of the meter length of the tube. Determine the average heat transfer coefficient between the water and the tube. Again, he is asking H. Assuming fully developed condition, also find the length of the tube for the bulk. Okay, case 2. He is asking case 2, length of the tube. If the temperature of the water rises from 25 to 55, that means T2, 50 degrees centigrade. If it is rises from T2, 65 degrees centigrade. So, what is the equation I supposed to, what step I supposed to solve for this? The first step should be finding the value of bulk mean temperature. What is the formula for bulk mean temperature? T bulk is equal to T1 plus T2 by 2. This is the formula. T1 is known 25, T2 is known 50 divided by 2, you will get a bulk mean temperature. Second step, properties at TB for water. Then after that, you find out Reynolds number. Reynolds number is given is 1600. So why is given here? Can you tell why the Reynolds number is given? What is the difference in the previous and this problem? In the previous problem, there he used to give the mass of the fluid flow. Mass of the fluid flow, how much it is, he was given. But here mass of the fluid is not given. So if the mass of the fluid is not given, I cannot find out what is the velocity of the fluid which is flowing. So instead of giving the mass of the fluid, he has given Reynolds number. So Reynolds number is so much, and this will be equal to rho Vd by mu. So any rho will get from this, mu will get, diameter is known, velocity I can take out from this. Correct? You take out the velocity from this equation. Velocity is 0.029 meter per second. So two ways to find out the velocity. One is if you know m dot is equal to rho a v. Find out v from that. If you know Reynolds number, substitute directly and equate Reynolds number given and this, find out the velocity. Once the velocity is known, find out m dot now. Now m dot is equal to rho a v. Rho will get from the right-hand from the properties. A is pi by 4 into d square. Velocity is 0.029. You will get m dot. See, there are no multiple tubes. There is only one tube, so that m dot will get kg per second. One tube. Yes, I'll write the answer. M dot I got as 0.0568. And this TF I not written. This TF value you got as, you check out and then get the value of TF. Anyhow, T1 is now 25, 50. I think it is 22.5, I guess. I'll take 25. 22.5, I'll take 23 and try to solve the properties. Then once the m dot is known, hence the Reynolds number is given himself as 1600. We can write a note directly as case 1, it is laminar flow. For case 1, it is a laminar flow. If it is laminar flow, what is the Nusselt number for the laminar flow? For flow inside the tubes, Nusselt number for laminar flow for the flow inside the tubes. Inside the tubes, how much it is? I got 4.36. You check out the Nusselt number for laminar flow. I got 4.36, and then Prandtl number you will get in your. So Nusselt number again is equal to H D by K. Take out H from this. H is watts per meter square Kelvin. This is considering the given Reynolds number. Again, I am repeating. This is considering the given Reynolds number. We got this. Done. Then what is asking for case 2 is asking length. All the condition remains same. For case 2 is asking to find length of the tube. So for this length, we'll go for the previous concept, that is, what is Q? Q he has given 800 watts per meter length. So that we want L, no? So what I'll do, 800 into length, that is equal to m dot Cp T1 minus T2. This is the law of conservation of energy. 800 he has given per meter length. This is the total heat transfer. M dot Cp, m dot we got 0.05. So that L is equal to 0.0568 into Cp, hence it is water, 4.183 into 10 to the power of 3. T1 is 25 minus 50 whole divided by 800. So take out the value of L, length of the heat exchanger. Length of the tube for the convection. So I got length as 7.43 meters. I got the length of the tube as 7.43 meters. You please check out, cross check the values. Please cross check the values. See, in some problem he will, as the Reynolds number is given, in some problem he will give, take the Nusselt formula as something. So whatever the formula he has given to take, you take that Nusselt formula. Don't use the Dittas-Boulter's equation. If he has given, if he has mentioned to take the Nusselt number as so and so, don't use Dittas-Boulter's equation. You must consider that Nusselt number. In the next problem, I will show you what to use if the Nusselt number is given. Okay. I hope you are completed. So till now, whatever the problems we have solved, it is internal flow and the fluid was water. Now we'll go for internal flow, means the flow is taking place inside the tube, but the fluid is air. I'll solve this problem. I'll wind up this module. Okay, I'll wind up this chapter in this module, forced convection. Say any doubts, you please discuss. Okay. We'll go for this problem. You take out, open this problem. Air at 2 atmospheric. See, till now we have solved the problem, everything working under 1 atmospheric pressure. The air which is flowing at an atmospheric pressure, we know how to solve. If the air is flowing at some atmospheric pressure or some pressure other than atmospheric, how to solve the problem? Air at 2 atmospheric pressure at 200 degrees centigrade is heated as it flows through a tube. That means inlet temperature of the air is 200. Once it is flowing through the tube, it is getting heated up. So that I can take out that temperature what is given is T inlet is 200 degrees centigrade and the pressure is 2 atmospheric. See, no data handbook in design, no Kodan data handbook will be having a properties at 2 atmospheric pressure. It will be having only for 1 atmospheric pressure. How to solve if the atmospheric pressure is 2 bar? I'll explain that. Okay. Flows through a tube with a diameter of 2.54 centimeter. It is 1 × 10⁻² meters. With a velocity 10 meters per second. Calculate the heat per unit length of the tube. It is, he is asking Q per unit length. How much? That is watts per meter. He is asking how much it is. If constant heat flux condition is maintained at the wall and the wall temperature is 20 degrees centigrade, T wall is 20 degrees centigrade. Above the air temperature, 20 degrees centigrade above air temperature. See, this is important. I cannot take 20. Just there is a tube. Inside the tube, air is flowing and the air temperature is 200 degrees centigrade. The wall temperature is 20 degrees centigrade above T1. So T1 is, this is called T1. T1 is 200. Wall temperature must be greater than that 200. Then only the air will get heated up. So T wall is 220 degrees centigrade. This T wall. Then, along with the length of the tube, how much would be the bulk temperature be increased over the length of the tube of 3 meters? So length is 3 meters. And what he is asking there? He is asking bulk temperature. That means I can write like this. He is asking what is T2. So what is T1 in this? T1 is 200. T wall is 220. And what is T2? T2 will be this one. Outside will be T2. Means I drop this one. If the air is flowing at this location, the temperature is T1. At this location, temperature is T2. T1 is 200. T wall is equal to 200, 220. He is asking this temperature. Clear? He is asking the temperature. And the flow is taking place at 2 bar. So how to do that? So how to do that? So what I do now, I will take the properties at, because T2 is not known, and if it is there also it will be not much than 200 because the surface itself is 200, 220, and this fluid inlet is 200. This may be within 220 only, less than 220 only, definitely. So I take T mean, or just I take properties at T1, that is 200 degrees centigrade, at P is equal to 1 atmospheric. Let us take first properties at 1 atmospheric pressure. So for in that row we got as 0.746 at 1 atmospheric pressure. We want 2 atmospheric pressure. So what I do? Very simple thing is, exact thing means you have to go for the data handbook of thermodynamics. You have to take the density of the 2 atmospheric pressure at temperature of 200. Now that is not available. So what I do? Just I'll multiply this into 2. It is 1.492 at 2 atmospheric. Just I'm multiplying this for 2 atmospheric pressure. It won't be much difference. So that is a row. With respect to that, you take the remaining. That is PR. Prandtl number, either it be 1 bar, 1 atmospheric or 2 atmospheric will be same. Then mu You take the value K, then Cp. This is all we are taking with respect to air, not with respect to water. So I'll write the properties. Please cross check or verify once again. Frontal number I got 0.68 and mu I got 2.57 into 10 to the power of minus 5. K 0.0386 and Cp 1.025 into 10 to the power of minus 3 into 10 to the power of 3. So this is the value of properties I got at temperature 200 and pressure 2 atmospheric. Then the remaining procedure, what is the next step after getting the property? Reynolds number, rho v d by mu. Velocity is given, so no need to take the value of m dot. Directly velocity will get. Rho is obtained now. Rho we got here. Velocity I take this, diameter is given, mu is also obtained. So I got Reynolds number as 14746. 14746. So for a tube, any fluid, if it is flowing in a tube, if the Reynolds number is greater than 2300, then it must be definitely turbulent flow. So the flow is, you write a note. The flow is turbulent because for pipe, RE should be less than 2300. For laminar flow, RE should be less than 2300. Now it is greater than 2300, so we'll consider it as a turbulent flow. So once you know it is a turbulent flow, what is the Nusselt number equation? See, all the problems in this is similar. Just here and there, small changes in the convection chapter, force convection chapter. So you can easily score good marks. So after this, what is the Nusselt number for a turbulent? Once you know it is a turbulent flow, take out Nusselt number as Ditter's-Boelter's equation. That is, Nusselt number is equal to 0.023, Reynolds number to the power of 0.8, Prandtl number to the power of n. If the fluid is heating, take the value of n as 0.4. If the fluid is cooling, take the value of n as 0.3. That is there in the diagram that he has given. After this formula only he has given. Okay, that's how you should take the Ditter's-Boelter's equation. In some problem, what he will give, just you observe it carefully. In some problem, what he will give, he will not ask you. He'll ask you to find out whether it is a laminar, turbulent, Deutsch. You find out. Then he will be giving two formulas of Nusselt number in some problem. Just I'll rewrite this. In some problem, if he has given the Nusselt number, consider the Nusselt number as 0.021 plus Bechtel number to the power of 0.4. Something he'll give for laminar flow, and Nusselt number is equal to 0.023 Bechtel number to the power of 0.4 plus something he'll give like this. So for turbulent flow, if he has mentioned in like this any equation, that equation is not standard. He can give any equation for Nusselt number for laminar flow and Nusselt number for turbulent flow. If not given, then no need to worry. Directly go for the data handbook. For turbulent flow, take Ditter's-Boelter's equation. For laminar flow, take the very first equation. That it will satisfy. If not, if he has given, then you should check out this, whether it is a laminar or turbulent. Once you come to know it is a turbulent flow, go for this equation, which is given in the question. Which is given in the question, you're supposed to take that. He can give something like this, Bechtel number plus 5 into 2, something he'll give to confuse. No need to worry. You use that equation for Nusselt number, proceed. So you may ask that what is the meaning of Bechtel number? We are not solved till now. What is Bechtel number? We know only Reynolds number and Prandtl number. This Bechtel number, you go for the data handbook in the page of 111, what I shared in the Google Classroom. In that page number P111, if you go, Bechtel number is a product of Reynolds number into Prandtl number. It is there. So first you find out Reynolds number, anyhow you found out here. Prandtl number you will get from the properties. Multiply that, you will get Bechtel number. Like that, whatever the formula, in whichever the form he gives, all these non-dimensional numbers is available in page number 111 in the data handbook what I have shared. I don't know what book they will give in exam. They will give Kodandraman only, but page number will not be same. You check out what equation they are given. Corresponding to that, you find out and find the value of mu. So now for this problem, he has not given that. He has not given anything. This he has not at all given for this problem. So what I'll do? If not given, go for 0.023. parental number to the power of n, Reynolds number to the power of quantity. That's all. If he has given, use this. So find out the n, Nusselt number you'll get. Once you get the Nusselt number, what is the next thing to do? Nusselt number is equal to hd by k. Take out what he's asking. He's asking t to know. So Nusselt number is hd2 by k. You take out the value of h from that. I'll take the value. For this Nusselt number, I got 42.64 is a Nusselt number. If you use that Nusselt number and if I find out the value of h, it will be h is equal to 64.77. This is the value of h I got for this Nusselt number. If he has given the Nusselt number, use that. Find out Nusselt number. This will be same. N is equal to hd by k. This is standard. Only this may change depending upon the condition. So you'll get Nusselt number. Once you get the Nusselt number, you go for the formula of Q. What is the Q formula for convection? Q is equal to HAT wall minus T fluid. So here T fluid is very challenging. 64.77. Area is pi dl. Just a minute. Area is pi dl. See this area is pi dl. If you are substituting in m dot, area should be pi by 40 d square. Remember, put a star mark and remember, if you are substituting in this formula, in this Q, this is supposed to be pi dl area. If you are substituting in there, area should be pi. Then what is T wall? T wall he has given us 220. And what is T fluid? T fluid he has given only inlet, but we should consider outlet also. So what is the formula for this? For this formula is T1 plus T2 by 2. This is nothing but bulk mean temperature. This is nothing but the bulk mean. I can rewrite this equation like this. T wall minus T bulk. I don't know the bulk mean temperature. Why I have not done the bulk mean temperature at the beginning? Because outlet temperature of the fluid is not given. So I cannot find out the bulk mean temperature. So bulk mean temperature formula is this: T1 minus T2 by T1 plus T2 by 2. T2 is unknown, so I have not done the bulk mean temperature at the beginning. Just a procedure. But in generally, what we'll do, we take the properties of the fluid at bulk mean temperature. But in this problem, I have taken the properties at T1 only. Why? Because T2 is unknown. I cannot take the properties at T2. So I consider T1 only and a procedure. Finally, this is the formula. Here everything is known except T2. Take out T2 in this equation. Take out T2. What is T2 in degree centigrade? And then he is asking bulk mean temperature. What is bulk mean temperature? TB. You find out TB also in degree centigrade. Once you know T2, you know what is the formula for bulk mean temperature? T1 plus T2 by 2. Without T2, I cannot get bulk mean temperature. That means indirectly T2 is asking. See this problem while preparing, prepare carefully. Yeah, because this is, and you write down this. This is also important. When I supposed to use an Nusselt number from the data handbook? When I supposed to use an Nusselt number from the given question? That depends upon each question. Nusselt number formula will not be same for each question. For laminar it will be different. For turbulent it will be different. Copy that fast and tell me the value of T2 and TB. I'm waiting for the answer of T2 and TB fast. Almost I have given everything. Just you substitute in that. Q is also given. Q by L is something. Whether Q is given. Whether the value of Q is given. You check out how to find out. In that equation, Q is also unknown. T2 is also unknown. How we are going to solve the first? How we are going to solve the T2? How we are going to get? See, that is a procedure to get T2. But left hand side is Q. The Q is also not given in the question. You have to find out what is the Q first. So to find out the Q is equal to M dot T2 Q. So equate this and that. That means M dot equal to 6 ideal 220 plus T2 by 2 Q2 T2. But again, still it is something is unknown. What is unknown? This still something is unknown. What is unknown? M dot is unknown. So what is M dot? M dot. So here I substitute rho V. So rho into velocity. So this is the value of M. Substitute this here. I'll rewrite the entire equation. Rho into d square into velocity into Cp T2 minus T1. This is the left hand equation. And right side is 6477.77 pi. What is D? D is 2.54 into 10 to the power of minus 2 into L whole multiplied by 220 minus T1 plus T2 by 2. See, this is the equation for finding T2. So something will get cancelled off. You try to cancel off that. D square and this D. Then what else will get cancelled off? Only that much. Rho D V Cp by 4 T2 minus T1, that is equal to 64.77 into L into 220 minus T1 is 200, no? 200 minus T2 by 2. So this is the equation. Find out T2 in this. So this is somewhat combination of the basic knowledge as well as this chapter. So prepare this carefully. Can you tell T2? Anybody can tell T2 and T bulk? What is T2? Hello? You people are there? Hello? The names. Neerav? Neerav, are you there?
Yes, sir.
Can you find out the value of T2?
Doing, sir.
Okay, calculate. See, all of you, please try by your own calculator and data handbook, then only you can learn. If you just copy what I have written in the board, prepare for exam. Because if you see the data handbook in forced convection, hundreds of Nusselt number equation you get. This equation, you'll get hundreds of equation of Nusselt number. So out of that, which one to pick for which problem is important. So you have to go and learn by using a data handbook for all the problems. Then only you can understand which one is suitable for particular problem. Anybody having doubt, please ask me. Don't hesitate to ask the doubts. Ask me and clear the doubts. In the next class, I will start up the free convection in the same module, next chapter, that is free convection. It will not take more than 4 classes. Free convection I can complete within 4, maximum 5 classes, that's all, not even 5. because all the topic I covered here. They are also same procedure, but just Nusselt number we will take with respect to free convection. Here all the thing we are taken with respect to forced convection. There we will take with respect to free convection. That's all. Procedure remains same for free convection also. Only small change. Here velocity is considered. There velocity we are going to find out by some other method. Velocity of the fluid here. Forcefully he will use the velocity will be of the fluid will be supplying by some other means. That is, he has given 10 meter per second. No, so here this value of velocity is obtained with by forcefully. When there is some other means to get this 10 meter per second. But in natural convection, this velocity is not given. You should find out what is velocity for natural air without having any external agency. How velocity is get obtained. First, you should find out that. Then same procedure. Bandhan bro, anybody got the value? Okay, I'll tell the 62 degrees centigrade. T2 is 262 degrees centigrade. 262, huh? I'm not sure. Please check out. Okay? I don't know. You check the value of this T2. Okay. You please calculate. I hope you'll calculate T2 and also bulk mean temperature. You please calculate it. With that, this module is this chapter is completed under this module. If you're having any doubt, please ask me. Or else please type your USA number, you can leave the class. But in the notebook, you please find out the value of T2 as well as T bulk. Keep it with you.
Hello, sir.
Yeah, tell me.
Sir, ನಂದು ಮಾರ್ಕ್ಸ್ ಇದು ಬಂದಿಲ್ಲ ಸರ್, ಇನ್ ಪ್ರೋಗ್ರೆಸ್ ಅಂತ ಬಂದಿದೆ.
ಯಾರು?
Janesh sir.
Janesh, it is cleared. It is cleared after considering. I mean, after consulting the concerned person. So your marks is cleared. I'll share that.
Okay, sir.
I think check out. Wait. I'll check out the marks and I'll tell you now only. Janesh, Allah. US semester?
400 sir, only 18 and 400.
Ganesh Kumar Gowda. It is 9.
Okay, sir.
Your overall marks is 9. Okay.
Okay, sir. Thanks.
Is there any other issue?
ಇಲ್ಲ sir.
Okay. All of you, please type your US number. You can leave the class. If you're having it out, you can discuss.